This is the setup for the energy conservation with the spring activity. The purpose of this activity is to show that the gravitational potential energy of this object, of this mass, the potential energy of the spring, and the kinetic energy of the mass will all add up to the same value if you let go of it. After you let go of it, as it drops, the potential energy, gravitational potential energy will decrease. The potential energy in the spring will increase, and the velocity will increase and then go back to zero. And so we're going to look at it at the beginning, in the middle, and the end. The first thing you'll need to do, and I don't show this, is find the spring constant of the spring. Don't trust the values on the boxes if you see those values. They're not very accurate. So find the spring constant of the spring just like you did in the Hooke's law activity. That's the first thing you need to do. Then I don't know how much it helps to put the cross on here. I tried it. That's how I did the lab. You can put the tape on there and see if that helps, or you can just try to, we're going to measure velocity with our blue dots. So you can either do that or you can just try to find the edge of the object. Either way will work. You do need to put a meter stick up there. So the first thing you'll need to do, the second thing after you find the spring constant, is set up a yardstick so you can set a reference point. So you can put two white dots and have a reference frame, because we're going to need the iPad, the video physics, to find the velocity force. We can't use our game of average velocity because the spring is always making the acceleration non-constant, so that doesn't work. You notice I've got my grid set up to where the vertical axis lines up exactly with the spring, and then I moved, after I picked the spring up, I set the origin to be right in the center where I was going to keep track of it dropping. If you decide to use the bottom edge of the mass, then you should set your origin there. It makes life simpler if the first distance is 0. Just makes it less work for you in the long run. So as your instructions will tell you, the first thing you did was we found the spring constant, and we've set up a frame of reference, a reference distance, so we can use our blue dot method. Then you just let it drop. I've already put my blue dots on, and you can see even with the white cross it really gets blurred. So what I basically did was put the blue dot in the middle of the white, and my results turned out reasonable. That's going to be our biggest error in our lab, is trying to determine the same spot on the mass. If you want to try to use the bottom edge or top edge, whatever you think works best is fine. So you just let it drop, and you need blue dots from the beginning. One thing I did, so while it was not before it started moving, 2 or 3 frames before it started moving, I put 2 or 3 blue dots right on top of themselves. Of course, you really can't see it because it looks like I'm not putting a second one, but I put 2 or 3 before it started moving, and then I started adding the blue dots. And as you can see from that yellow dot, I tried to put it right in the middle of the white. Just do the best you can. That's the hardest part of the lab. Then once you do that, after you need to have blue dots all the way down to the bottom once. Okay? And I did 1 or 2 dots on the way up just so I could make sure I found the bottom. Then we want to open this in graphical analysis. Go to the table. And you notice, by the way, just a reminder, this E is scientific notation. If you've got 10 to the negative 8, it's 0. So my Y velocity, which is starts off at 0, and that you won't get 0 if you don't put a couple dots right on top of each other. So that's the reason I did that. My position in meters started off at 0. Then I'll look down here, and I'll have to enter this value in the table. As I found the farthest down it went was negative 0.3437. So that's in your table. That's going to be your H 2. Your H0, to find that, I found the biggest velocity, your H1. We want the biggest velocity. It looks like it's right here, so it's negative 1.13, and the X, the H1 that went with that, is 0.185. So those are the values that I do all my calculations with. So my initial position is 0. My middle position is based on the max velocity, which is right here in the table, 0.1849. My velocity starts at 0. My max velocity is 1.128. And my farthest distance down is right here. So I put that in the table. And I went ahead and entered this value. Theoretically, it's 0. And you're going to find when we actually use it, if I use this value, the kinetic energy is so small it doesn't really affect my results. So that's all you have to do to collect the data. And you'll do it for 2 different springs. Now I'll go to the lab notebook and show you what to do with that data. Good luck.